Hey everybody, Marcus Brownlee here. Today we're diving deep into the world of Android. It's the most popular mobile operating system out there. You see it on phones, tablets, even in cars and wearables. Android's known for its open source nature and its flexibility, which is why it's everywhere. But have you ever wondered what makes it tick? We're going to explore the inner workings of Android, from its architecture to its security features to the hardware it runs on. Android's architecture is like a layered cake, each layer with its own purpose. Each layer builds upon the one below it, creating a robust and versatile system that powers millions of devices around the world. At the bottom, we have the Linux kernel. Think of this as the foundation of the house. Just like a strong foundation is crucial for a stable building, the Linux kernel is essential for the stability and performance of the Android operating system. It handles all the low-level stuff like memory management, process management, and hardware drivers. These are critical tasks that ensure the system's core functions operate efficiently and reliably. It makes sure everything runs smoothly at the most basic level. Without the Linux kernel, the higher layers of the Android architecture wouldn't be able to function properly. Above the kernel, we have libraries. These are pre-written pieces of code that developers can use to build apps. They save time and effort by providing reusable code for common functions. These libraries provide access to things like multimedia, databases, and graphics rendering. For instance, if you're developing a game, you can use graphics libraries to handle complex rendering tasks without writing all the code from scratch. It's like having a toolbox full of useful tools ready to go. Developers can pick and choose the libraries they need to create powerful and efficient applications. Next up is the Android runtime. This is where your apps actually run. It's a crucial layer that ensures your applications perform well on various devices. It includes the Dalvik virtual machine, which is optimized for mobile devices. The Dalvik VM is designed to be lightweight and efficient, making it perfect for the limited resources of mobile devices. Think of it as the engine that powers your apps. Just like a car engine converts fuel into motion, the Android runtime converts your code into actions that the device can perform. And finally, at the top, we have the application framework and the apps themselves. This is the layer that users interact with directly, making it the most visible part of the Android architecture. This is what you interact with directly. The application framework provides the building blocks for creating apps, offering a consistent environment for developers. The framework provides access to system services like the phone, camera, and location. These services are essential for creating feature-rich applications that can leverage the full capabilities of the device. It's like the interface between your apps and the underlying system. The application framework ensures that apps can communicate with the hardware and other software layers seamlessly, providing a smooth and intuitive user experience. Security is paramount in today's digital landscape, and Android takes it seriously. At the OS level, Android uses sandboxing to isolate apps from each other. This means that even if one app is compromised, it can't access data from other apps or the system. It's like each app has its own little sandbox to play in. Android also enforces app signing. This means that every app has to be digitally signed by the developer before it can be installed. This helps to verify the authenticity of apps and prevent the installation of malicious software. It's like a digital signature that verifies the app is legit. And when apps need to communicate with each other, Android provides secure mechanisms like intents and services. These mechanisms ensure that data is exchanged securely and that only authorized apps can access sensitive information. It's like having secure channels for apps to talk to each other. Beyond these foundational security measures, Android's security team is constantly working to stay ahead of potential threats. Regular updates and patches are rolled out to address vulnerabilities and enhance security features. Users are also encouraged to enable two-factor authentication for an added layer of security. Reviewing and managing app permissions is another crucial step users can take to protect their data. Developers play a key role in this ecosystem by rigorously testing their apps in secure environments before release. The Google Play Store also employs Play Protect, which scans apps for malware and other threats. If a threat is detected, users are promptly alerted and guided on steps to secure their devices. From hardware-based security features to software-level protections, Android's multi-layered approach ensures comprehensive security. This multifaceted strategy helps users feel confident that their data and privacy are well protected. With continuous innovation and vigilance, Android remains committed to safeguarding its ecosystem for all users. Stay secure with Android. Now let's talk about the hardware that powers your Android device. At the heart of it all is the processor, or CPU. This is the brain of the device, responsible for executing instructions. It's like the engine that makes everything run. Then you have the memory, or RAM. This is where the device stores data that it's currently using. The more RAM you have, the more apps and data you can access quickly. It's like having a bigger workspace. Storage is another important component. This is where your apps, photos, videos, and other data are stored permanently. It's like the hard drive of your device. And of course, you have all the peripherals like the display, camera, GPS, and sensors. These components allow you to interact with the device and the world around you. It's like the sensors of your Android device. Section 5, booting up the Android startup sequence. Ever wondered what happens when you press the power button on your Android device? It's a process that happens in the blink of an eye, but it's incredibly complex and fascinating. The boot process is a fascinating sequence of events. It involves multiple stages, each crucial for the proper functioning of your device. First, the bootloader kicks in. This is the very first piece of code that runs when your device is powered on. This is a small program that initializes the hardware and loads the operating system. Think of it as the conductor of an orchestra, ensuring every component is ready to play its part. It's like the ignition switch of your car. Without it, nothing else can start. Once the bootloader does its job, the Linux kernel takes over. The kernel is the core of the operating system, managing everything from memory to hardware communication. It loads into memory and starts essential system services. These services are the backbone of your device's functionality. It's like the engine coming to life. Without the engine, your car wouldn't move an inch. Next, the Android runtime starts up and the system services are initialized. The Android runtime, or ART, is responsible for running apps on your device. This includes things like the Window Manager, Notification Manager, and Package Manager. These components ensure that your apps can display properly, notify you of important events, and manage app installations. It's like all the systems in your car getting ready to go. The dashboard lights up, the control panel activates, and everything is checked to ensure a smooth drive. Finally, the home screen launches and your device is ready to use. This is the moment when you can start interacting with your phone, opening apps, and performing tasks. It's like putting your car in drive and hitting the gas. Now you're ready to go wherever you need to with your Android device fully operational and at your service. Section 6, setting up your Android Forensic Lab. Now let's shift gears and talk about Android forensics. Setting up a forensic environment might sound complicated, but it's actually pretty straightforward. You can start with an Android virtual device, or AVD. This is basically a software emulation of a real Android device, and you can customize it to your liking. It's like having a virtual Android phone on your computer. Section 7, connecting and accessing Android devices. To analyze a physical Android device, you'll need to connect it to your computer. You can usually do this with a USB cable. Once connected, you might need to enable USB debugging on the device. This allows your computer to communicate with the device in a special mode that's useful for debugging and forensics. It's like opening a back door to the device for analysis. Section 8, essential tools for Android forensics. There are tons of tools available for Android forensics, both free and paid. One popular option is Autopsy. It's an open-source platform that provides a graphical interface for analyzing disk images and mobile device data. Think of it as your digital detective toolkit. Another powerful tool is Cellebrite UFED. This commercial tool is widely used by law enforcement and forensic investigators. It supports a wide range of devices and can extract data from various sources, including apps, databases, and the file system. It's like having a master key to unlock data. Section 9. Conclusion: the importance of understanding Android inside and out. So there you have it, a deep dive into the world of Android. We've covered a lot of ground, from the architecture and security to the hardware and boot process. But most importantly, we've explored the fascinating world of Android forensics. Understanding how to set up a forensic environment, connect to devices, and utilize forensic tools is crucial in today's digital age. Whether you're a security professional, a developer, or just a tech enthusiast, having a solid understanding of Android can be incredibly valuable. Stay curious, keep exploring, and I'll catch you in the next video.